A warm welcome to all the students. In this lecture, we shall continue our discussion on classes and objects. Today, we shall see what are static members. Okay. Now, first let us see the syntax of declaring static members. You have a keyword called as static. Suppose I want to declare an integer, say count, as static. Similarly, so this is basically static member. It is also called as class variable. Right, and there are also something called as static methods. Okay, they are also called as static member functions. The syntax of static method is like this: static int, suppose say max is the function that you want to make it as static, and the body of the function. So this is how you declare a static member function or static method. Okay. Now, what is the advantage of declaring any variable or any function as static? What exactly happens? Let's see. Okay. Now, if I have a class, say student, okay, and in this student there are some variables, let us say int age and say int say count, that counts the students, and so on, and and so on. Now, what happens is when objects of this particular student class are created, for example, let us say S1, S2, S3, S4 and S5. There are 5 objects of this class called as students which are created. You will see that each object will have its local copy of age variable and count variable. Okay. So, each object will have its own local copy of age and count. So, this will continue for all the objects, right, and so on. Now, what happens is, if the first object, say S1, it modifies say the count, okay, then S2 will not be able to see that modified value of count. S2 will see its own local copy of count. Similarly, S3 will also be able to see only its own local copy of count, and so on. So, since age and count, they are local, their copies are there for each object, they are called as instance variables. Okay, they are called as instance variables. Right. Now, let us see what happens when a variable is declared as static. Now, I will just change this code and I will say static int count. Now, internally in the memory there is some change that is happening. First of all, this count variable is no longer property of the object, it is not part and parcel of the object. Okay. So, when a static keyword is associated with a variable, it is no longer an instance variable, it becomes a class variable, or in Java we call it as a class member. So, now graphically what happens is, okay, count has been declared as static. So, since it has been declared as static, you will have only one copy of this variable called as count. Let us say it is initialized to some value, say 10. All the objects, okay, all the objects will refer to that same copy of the count variable, right. So, all the objects will refer to the same copy of count variable. If one object modifies the count, all other objects will be able to see that modified value of count. right? So if one object modifies the content of the count variable, which is a static variable, all other objects will be able to see that modification. Okay. So all the objects will be accessing one common variable and its memory. Okay. So this is how the static variable works. Okay. So broadly speaking, the static variable can be used when we want to have a variable that is common to all the instances or objects of the class. Okay. Now where this is applicable, say if we want a variable that can keep track of how many objects have been created so far, okay, then you can use something like a a static variable. So here what happens, whenever any variable is declared as static, as I have shown you, Java creates only one copy of for the static variable. Java creates only one copy, okay, and this one copy can be then used by all the objects. Okay. Now this is regarding the static variable or static field, you can say, because now in Java variables are also called as fields. Fine. Similarly, class, okay. Now similarly, in a class you also have methods, right? Now the usual methods are called as instance methods, because each object, okay, that will have one copy of that. But we also have something called as static methods. So let us see now what is a static method and what is the use of this static method. Okay. So these methods, being static methods, they can be called without using objects. They are also available for the use by other classes. Okay. So if a class is, if a method is declared as static, example, let's say I also have a method over here, say void get data, okay, and there is some code in the get data. Now this particular method is also called as an instance method. Why? Because this get data method, okay, will be associated with each object. So this one will have get data. This get data function will access attribute a local copy of S1, that is age. Similarly, this also will have get data, okay, which when called will be able to access the local copy of object S2, that is age, and so on. Now I will do a slight modification. I will declare this variable, this particular method, I will declare it with keyword called as static. Okay. So when I declare this particular method as static, it's called as static method. Okay, it's called as static method. It is no longer an instance method, and since it's a static method, each object won't get one copy of that particular method. Rather, it will be a centralized method, and since it is a centralized method, it is not in the scope of any of the objects. Please note, this get data method is not in the scope of any of the objects, right? So when a method is called, when method becomes a static method, okay, that method is not in the domain of any object, but it is in the domain of the class into which it is created, right? So the method, that means this get data method, it need not be now called using object name. So something like s1 dot get data will not work. Why? Because get data is declared as static, it is not a part and parcel of the object anymore. So object and dot operator need not be used in calling get data function. Then how get data static method can be called? Okay, since it is in the scope of class, then the static method can be called using the class name dot and then the method name, static method name. Fine. So this is how it can be used. Okay. One example one example of the already existing static method is, you must have seen, we have already seen there is something called as math class. Okay. In Java there is java.lang, it has a class called as math class. Now all the different methods that we have seen, inbuilt methods that we have seen in math class, all those are static methods. Why? Because you have seen, suppose there is a method inside that's called as square root. If you want to calculate a square root, how do you do it? Say float x equal to, now this math class, it has a method called as square root, sqrt. But how do we call this method? So I will say float x, and to call this method I will use math, the class name dot sqrt, and then I will pass a value, say 5.3, sorry 510 or 5. Okay. So this is how this particular math class, which is there in java.lang, all its methods, inbuilt methods that we are using, all of them, they are static methods. Why? Because they can be accessed using class name and dot operator, not object name, right? So now few things that you need to see, you need to remember about the static methods. Okay. There are some restrictions with the static methods. The first restriction for static method is that, okay, they can only call other static methods. Okay. They can call only other static methods Second, they can only access static data. And the third one is that they cannot refer to this or super in any way. They cannot refer to this. Now, this is a keyword that we shall see later on as we proceed with Java. So, they cannot refer to this, or there is also something called as super. So, this is basically a super class in inheritance. So, this cannot be accessed by static methods. Fine. So, after seeing this, now let us quickly see one program for static member. So, here we have a class called as static demo. Okay. Now, what I will do is I will try to count how many objects are created. Okay. Now, let me create another class here. Okay. I will just create another class say class count. Class count is the name of the class. Okay. And in this particular class, okay, what we are doing is any object of this class is created. Okay, the static variable which we are going to declare, it is going to count the objects created of this particular class. Okay. So, the very first thing what we are going to do is we are going to create a constructor of this particular class count, and what this constructor will do before this we are going to declare a static data member. I will say static int count. Okay. So, count is a static variable which is declared in this class count class, and this static variable will not be in the scope of any objects of this particular class. Okay. So, we are going to use this variable to count the objects that are created. Now, as you know, whenever any object is created, the constructor is automatically called. So, in this constructor, once say the first object is created, in the constructor I will make this count increment by 1. Okay. I will make this count increment by 1, and I will simply print a message count, or I can say object created so far equal to, and I will just say count, I will print count. Fine. So, what constructor will do? Constructor will increment the count and it will print how many objects are created so far. Okay. Now, so this is the class count variable. This is the static variable called as count. Now, in the public static void main, let me create objects of this class count. Okay. So, I will first create an array of objects, because I need to create many objects. I will create array of objects. I will just say class count array array equal to, okay, equal to new class count, and let us say 10 objects. So, this is how I create an array of objects, a array to store 10 objects. Okay. And now, in this particular array that I have created, okay, each element of the array will be one object at a time, right. So, I will use a for loop now. For int I equal to 0, I less than say 10, I plus plus. I can even say I less than array dot length, I less than, I can say array dot length, that will give me the length of the array. Okay. And now, I will be creating the first object in the first index position. So, array of I equal to new class count. So, I will be creating a new object every time. So, in this particular first iteration I is 0. So, a new object will be created and the reference name will be the array of ith location. So, array of ith location will be a reference name pointing to that object. Okay. In the second iteration I will be 1, 1 is less than length. So, array of 1, that is the 0th index is over. Now, the first index position will be the reference name for the second object and so on. Okay. So, and after I come out of this for loop, I can simply print the count. Okay. I can simply print the count. So, what I will say, system dot out dot println, okay, total number of objects created are, okay. Now, I need to print the total number of objects that are created. So, I require a function also, okay, I require a function also, and I will call that as a static function. Okay. So, one static member I have already created. So, I will just create a static void, okay, print function. What this print function will do is it will simply print the total number of objects that are created so far. So, instead of printing it here, I will cut this and I will try to do it inside the static function. Total number of objects that are created are, and I will print count, the final value of count. Okay. So, now after creating 10 number of objects, when you come out of the for loop, you can then call this print function to find out total how many objects are created. Again, print function is a static member function or static method. So, first thing, it is not in the scope of the object of that class. So, it has to be called using class name. So, I will use class count dot print. So, I will just say class count that is the class name dot, I will call this print function, which is a static function. So, this function call will it will print the total number of objects that are created. Also note, the static member functions can only access the static variables. Okay. So, I will save and I will run this program, and you can see every iteration, like in the first iteration when the object is created, what will happen is the constructor will be called automatically in constructor. In the constructor, count will be incremented by 1. So, count becomes 1 initially, then it will print object created so far is 1. So, you can see this line when the very first object is created. Okay. Then after that, I is incremented by 1, from 0 I becomes equal to 1, 1 is less than length of the array. So, again it will come here at array of 1, that is the first index position, again a new object will be linked, created, and it will be linked to the reference name, that is array of 1. Okay. Now, when object is created, automatically again the constructor will be called, and within the constructor this count will be incremented by 1. Okay. So, count earlier was 1, now count becomes 2, and this line is printed, object created so far is 2, and that is why this second line, object created so far, becomes equal to 2. Notice that this count is not in the scope of the object. If it was in the scope of the object, then what would have happened? Every time that a new object is created, this count variable would be initialized to a different value. So, you will have multiple copies of this count variables if it was not a static variable. Now, what is happening? Now, even before the object is created, this count variable exists, and when the first object is created, this count variable is incremented by 1, and that is how you get this. Also notice that after printing all the objects created so far, I have called this print function, which is a static function, static member function, using class name and dot operator, and as a result it finally prints that there are 10. So, count is 10 finally. So, it prints that there are 10 objects which are created. So, this is a simple demo to show you how static member functions and static fields can be used. Here is another program wherein I am creating a class called as math operations, and I am writing two static methods. One is mul, that basically performs the multiplication of two input floating point values x and y, and it returns the multiplication value x into y into the main. Similarly, another static method that I have written is divide method. It also receives two parameters and it returns the division of those two parameters. So, this is basically a class called as math operations. Now, through void main, I am calling this particular mul method. Please note, students, that since they are the static methods, I do not have to create object of math operations class. That is why you do not see any object of math operations class being created. I am declaring a floating point variable a. Now, I am calling this mul multiplication function using the class name and dot operator. So, you can see here math operations dot mul. I am passing two values 2.0 and 5.0. F specifies that they are floating point values. Okay. So, this particular function will be called, it will perform x into y multiplication and it will return the value. The return value is going to be stored in variable a, floating point variable a. Similarly, second, math operations dot divide will call the static method called as divide, and it will pass a that is the previous answer what we have got as the first parameter, and 2.0 is the second parameter. So, x will be that a value, y will be 2.0, and it will return the division value, and that will be stored in b. And finally, I am just printing the value of b. Okay. So, you can see that although there is another class called as math operations that we have created, I do not have to create any object of that class. Why? Because there are only two static member functions or static methods, okay, or class methods you can say, and that is why no object is to be created. Let us run this. Okay. So, the answer of this will be 5. Okay. So, it has multiplied 2 and 5. Okay. that is 10 is the answer, and then A is 10.0, okay, and 10 and 2, when you perform division, the answer is 5. So that's why the answer is 5. The next concept that we are going to see is nesting of methods, wherein one method, it calls another method within the definition of it. So to do that, to see that, let us quickly see a small program. Okay, I have created a class called as nested method demo. Okay, I am declaring two integer values, say m and n, and let's say I want to find out the largest of two numbers. Okay, so to do that, I will be creating a class called as largest. Okay, I will declare it here, class largest, fine. In this class you declare two variables, int a comma b, two variables. Now I will write the constructor of this class, okay, and we will take the values of a and b, say x comma int y, okay. Then a will be x, b will be y. So this is the constructor. Now the first, I will be writing two functions. The first function is going to find out the largest of two numbers. Okay, so it will compare a and b, and whichever is the largest one, it will return that. Since a and b both are of type integer, the return type of this function also is int. So int largest. Now it compares the value here. So if, okay, if a is either greater than or equal to b, okay, then what we are supposed to do? Then it will return a, okay, it will return a, else it will return, say, b, a simple code. So whichever is the largest value, it is going to return, fine. Now there is another function that we are going to write, display, which is going to display that who is largest, who is smallest. So display. Now nesting, I call this program as nesting program because you see the calculation of largest is going to happen here, right, but I am not going to call this largest function separately in the main, right. Rather, I will be only calling this display function, and display function internally will call this largest function. Again, students note, it is a simple function. This thing is not a, it's not a constructor. Okay, so don't get confused because I have written largest here, largest here. So I will just change the name of the function here, largest number. Okay, the function name is largest number, whereas constructor is largest, class name is largest. Okay, so display function first will find out who is large. So it will declare a variable called as large, and it is going to call now largest number function. Okay, it is going to call this largest number function or method, and this largest number function or method is going to return who is largest based on the values of a and b that are passed here. Okay, whatever is returned, that will be stored here, fine. And then I am going to just print a message that the largest value is large. The largest value is, and I will say plus large, whatever is stored in that large variable. Okay. So now in public static void main, I am going to create object of class largest. So, I will say largest, say L equal to new largest. Okay. And note that in the constructor I am supplying the value of A and B. So, let us supply it here largest. Let us say A is say 7 and B is say 2. Yes. So, A will be assigned value of x, that is 7, B will be assigned the value 2. Okay. Then actually the largest has to be calculated, but I am not going to call this largest function. I am going to call display method. So, I will say L dot display. So, I am going to call this display method. Now, what will happen is display method will be the definition will be accessed here. Now, display method within itself is calling the largest number method. Okay, this largest number method. So, largest number method will calculate which one is the largest number and it will store the answer in large, and it will print the the largest value is large. Okay, so, this is called as nesting of functions, because I am calling one function, that is largest, within the definition of another function called as display. So, in main I am just calling one function and other will be automatically called internally in the display function itself. So, I will save this, and you can see the largest number is 7 out of 7 and 2.